In the late 1960s, at the height of the Cold War, intelligence analysts working for the CIA were scanning routine satellite imagery of the Caspian Sea when they spotted something that completely defied all logic of conventional aviation. Sitting in the water was a machine of gargantuan proportions. It was over 300 feet long, weighed more than 500 tons, and featured the massive fuselage of a heavy bomber. Yet, it had incredibly stubby, square wings that looked mathematically incapable of generating enough lift to get this Leviathan off the ground. American intelligence dubbed it the Caspian Monster. It was moving at over 300 miles per hour, yet it never climbed higher than 30 feet above the waves. It was not a conventional airplane, and it was most certainly not a boat. This machine belonged to an entirely different classification of vehicle known as an achronoplan, a craft designed to exploit a bizarre aerodynamic phenomenon known as the ground effect. For decades, standard aviation saw ground effect as kind of a nuisance, this dangerous quirk of physics that caused planes to float over the runway during landings. But Soviet engineers, they looked at the same exact physics problem and saw the future of high-speed, heavy-lift transportation. So today in this video, we are going to explore the incredible aerodynamics of ground effect, the terrifying Soviet war machine built to harness it, and why this seemingly brilliant concept ultimately vanished from the skies. To truly understand why the achronoplan works, we first have to understand why conventional airplanes struggle with efficiency. When an aircraft flies, the high-pressure air beneath the wings, as you can see, constantly tries to escape to the low-pressure area above the wing. Because the area cannot travel through the solid metal of wing, it spills over the very ends of the wings. This violent spilling creates swirling tornadoes of air known as wingtip vortices. And these wingtip vortices alter the airflow over the entire wing, tilting the total lift vector slightly backwards. And this backward component of lift is a massive aerodynamic penalty called induced drag. In traditional aerodynamics, the coefficient of induced drag is calculated using this fundamental formula, as you can see. In this equation, CL represents the lift coefficient, E is the Oswald efficiency number, and AR is the aspect ratio of the wing, which is the ratio of the wingspan to the wing's chord's length. As the formula demonstrates, induced drag is inversely proportional to the aspect ratio, AR. This is exactly why high-altitude gliders have incredibly long, skinny wings, which is a high aspect ratio, which means it minimizes those drag-inducing vortices. Now, what happens when you bring that wing incredibly close to the surface of the Earth? When an aircraft flies at an altitude that is roughly equal to or less than half of its wingspan, the physical presence of the ground or water completely interrupts the formation of these wingtip vortices. The ground acts as a hard boundary layer, pretty much. The high pressure air beneath the wing, however, has nowhere to escape and simply becomes trapped, creating a massive cushion of high density air. This phenomenon is called the ground effect, and it essentially tricks the airflow, which dramatically increases the effective aspect ratio of the wing without physically making the wing any longer. So by flying just a few feet above the water or ground, an aircraft can lift significantly more weight using a fraction of the fuel required for high altitude flight. The mind behind weaponizing this aerodynamic loophole was Soviet engineer Rostislav Alexeyev. He realized that if he could build a craft that lived entirely within this high-pressure air cushion, he could build a navy that moved at the speed of an air force. The ultimate realization of this dream was the Chronoplan class Loon, a terrifying war machine that took its first flight in 1987. This vehicle was essentially a flying missile cruiser, powered by 8 massive Kuznetsov turbofan engines and carried 6 enormous Moscow anti-ship nuclear missiles strapped directly to its spine. Building this 500-ton machinery does present a massive engineering paradox. Ground effect is incredibly efficient once you are moving fast, but water is incredibly sticky when you are sitting still. To overcome the immense hydrodynamic drag required to break free of the water, Alexeyev utilized a brilliant engineering trick called Power Augmented Ram, or PAR. Notice how all 8 jet engines on the Loon class are mounted at the very front of the aircraft, right behind the cockpit. Now, during takeoff, the pilots would vector the exhaust nozzles of these engines directly under the wings. By blasting high velocity jet exhaust directly into the enclosed space beneath the wing, they created artificial ground effect by literally blowing the massive craft out of the water before forward airspeed could take over. If an aquanoplan pilot attempts a steep bank while flying only 15 feet above the surface, the downward wing will instantly strike the water at 300 miles per hour. This would cause a catastrophic fatal cartwheel. Because they cannot bank, aquanoplans must make incredibly wide, flat turns, making them terrible at maneuvering around obstacles. Furthermore, ground effect requires a relatively flat surface to maintain the aerodynamic cushion. While oceans look flat from a cruising altitude of 35,000 feet, they are actually chaotic environments filled with unpredictable swells and rogue waves. If a wave strikes the underside of an acronoplan wing, it can disrupt the air cushion, causing an immediate loss of lift and sending the craft crashing into the sea. Flying these machines required intense, exhausting concentration from the pilots, who had to manually fly the aircraft mere feet above the water with absolutely zero margin of error. When the Soviet Union collapsed in 1991, the massive funding required to maintain these highly specialized machines dried up overnight. The mighty Loon-class chronoplan was dragged onto the beach, left to rust away as a bizarre monument to Cold War ambition. However, the physics of ground effect are far from dead. Today, modern aerospace startups are revisiting Alexeyev's dream, but on a much smaller scale. Companies are currently developing a fully electric passenger carrying sea gliders designed to operate as high speed coastal ferries. By keeping the vehicles small and operating them only in predictable, calm coastal waters, engineers believe that they can finally harness the incredible efficiency of ground effect for green, clean public transit. The conquest to conquer aerodynamic drag is a constant battle in aviation. In fact, if you want to learn how modern commercial jets fight the exact same wingtip vortices that the chronoplan try to avoid, you need to check out my deep dive video on the secret physics of winglets. Thank you so much for watching, and I will see you in the next one.